Hello students. Today we will discuss upon electric and magnetic circuits, which is the unit 1.1 in the subject Basic Electrical and Electronics Engineering. Myself Chandrasekhar S. Patil from Sharad Institute of Technology, Polytechnic, Yadra, Ichalganj. The contents of discussion will be basic concepts in electrical engineering, significance of free electrons, concept of potential difference, concept of electromotive force, concept of resistance, concept of power, and the concept of electrical energy. So, one by one, we will understand the basic concepts in electrical engineering which are stated in the contents of the index sheet. In the basics concepts of electrical engineering, energy of an electron. So, what is the energy of an electron? An electron moving around the nucleus possesses two types of energy. They are kinetic energy and potential energy. Kinetic energy is due to its motion around the nucleus, and the potential energy is due to the position or due to the charge on the nucleus. The potential energy is due to the charge on the nucleus. The total energy of the electron is the sum of these two energies. So, the energy of an electron is the sum of two energies, that is the kinetic energy due to the motion and the potential energy due to the charge of the nucleus. The energy of an electron increases as its distance from the nucleus decreases. So, as and when the electrons go far away from the nucleus or they are in the outer orbits, the energy of the electrons will be more and more, or it will be on the higher side. Valence electrons. The electrons in the outermost orbit of an atom are known as valence electrons. The outer orbit may have maximum 8 electrons. The valence electrons determine the physical and chemical properties of the material. So, we all know that every material is made up of atoms, and an atom consists of protons, that is protons and electrons. Protons and neutrons are in the nucleus, whereas the electrons are moving in the orbit around the nucleus. So, whatever the electrons are there near the nucleus, they are at the lower energy state and they are more and more stable. Whereas the electrons in the outermost orbits are highly unstable and they are at higher potential, or they have the higher amount of energy, and because of which they are easily liable to become the free electrons. So, they are also the outermost orbit electrons in the outermost orbit are called as valence electrons. Maximum 8 electrons can be there in the outermost orbits, or the 8 valence electrons can be possible. So, any material, the physical and chemical properties of the material depends upon the number of electrons in the outer orbits, or we can say that the valence electrons decides the physical and chemical properties of the material. Free electrons. These valence electrons, which are loosely attached to the nucleus of an atom, are called free electrons. So, at a time in a conductor, there are number of atoms, and each atom has some electrons in the outer orbits. They are called as valence electrons, and these outer orbits electrons are loosely attached to the atom, or loosely attached to the nucleus of the atom, and they are called as free electrons. So, what is a free electron? We will understand in detail, because we have to understand about the electrical energy. electrical energy, as we have studied in the first lecture, it is the rate of flow of electrons. So these rate of flow of electrons means the rate of flow of free electrons in the conductor. So we have to understand in detail about what is a free electron. The free electrons move at a random from one atom to another in the material. So they are always in motion from one atom to another in the material, and they are loosely attached to the nucleus. In fact, they are so loosely attached that they don't know to which atom they belong. They are always flowing in the conductor, and because they are so loosely attached, we can't say which electron belongs to which atom. It may be noted that valence electrons may be free electrons. It may be free electrons, but all valence electrons are not free electrons. Some of the valence electrons can be free electrons, which is the important point to be noticed. Conductor. A substance which has large number of free electrons at room temperature is called a conductor of electricity. Conductor is one in which number of free electrons are more, because of which it easily conducts that whenever a potential is applied or whenever a voltage is applied, it easily allows the current, or the current can flow easily through the conductor. The material which come under conductors or good conductors are copper and aluminum, etc. Insulators. A substance which has very few electrons is called an insulator of electricity. So as we have understood what is a conductor, similarly the opposite side of the conductor is the insulator. It means opposite to conductor is the insulator, which means there are very less few electrons, free electrons, and negligible amount of or no current flows through the insulator via practically whenever a voltage is applied to the insulator. So whenever a voltage is applied to the insulator, practically no current flows in the material. Examples: plastic, ceramics, etc. So for that purpose, plastic insulation we have creating for cables is the material used is plastic, and for bushings and isolators we are using the ceramics. Semiconductors. So the third category of material is the substances is the semiconductors. They are neither conductors nor insulators. They are crystalline substances and contain very few electrons. So as we all know, semiconductors are crystalline substances and very few electrons at free electrons at room temperature. Semiconductor behaves partially as an insulator. Because of the less number of electrons in the room temperature, we have the behavior of the semiconductor as an insulator. It partially behaves as an insulator. If suitable controlled impurity is imparted, controlled conductivity can be achieved. So if you impart impurities into the semiconductor substances, then controlled conductivity of the semiconductor material can be achieved. For example, the semiconductor materials are silicon and germanium. So by the doping techniques, we are introducing the impurities in the semiconductor material, and because of that we can achieve controlled conductivity, and at room temperature it behaves as an insulator because of the less number of free electrons. Whereas if the impurities are imparted or doped on the semiconductors, it can become a conductor, or it can be act as a controlled conductor. Concept of potential difference. So what is a potential difference? The difference in the potentials of two charged bodies is called potential difference. So in the diagram you can see that there are two objects or two bodies. First one is A and second one is B. The A is at plus 5 volts and the B is at plus 3 volts. So A is at a higher potential compared to B body. Body A is at higher potential compared to the body B. So for example, here each coulomb of charge on body A has 5 joules, energy of 5 joules. So body A has 5 joules of energy and body B has 3 joules of energy. If two bodies are connected through a conductor, the electrons will flow from body B to body A. When the two bodies attain the same potential, current stops. Okay. The potential difference between 2 points is 1 volt if 1 joule of work is done or released in transferring 1 coulomb of charge from one point to another. So the potential difference between the 2 points is 1 volts. If 1 joule of work is done, means amount of work done to move the electrons from higher if 1 joule of work is done or released in transferring 1 coulomb of charge from one point to another, then the potential difference is said to be 1 volt. Concept of EMF. EMF is nothing but electromotive force. A device that maintains potential difference between 2 points is said to develop electromotive force. Any device, maybe battery, it may be cell, wherever a potential difference is maintained by a device between 2 points, it is said to develop a electromotive force. A simple example is a familiar example which we all know is the voltaic cell. It consists of copper plate called anode and a zinc rod called cathode immersed in dilute sulfuric acid. So in the diagram we can see that there are two electrodes. On the left side we have the zinc electrode and on the right side we have the copper electrodes. And both these two electrodes are immersed in the dilute sulfuric acid which acts as the electrolyte. The chemical action taking place in the cell removes electrons from the copper plate and transfers them to the zinc rod. The transference of electrons takes place through the agency of dilute sulfuric acid called electrolyte. So whenever or as and when the two electrodes, zinc and copper electrodes, are immersed in the dilute sulfuric acid, what happens is the electrons transfer takes place from the copper electrode to the zinc electrode through the medium called as dilute sulfuric acid, which is the electrolyte. So the electrons or the free electrons are moved to the zinc electrode, which is the cathode here. So from anode to cathode, the electrodes through the dilute sulfuric acid, the electrons move from copper anode to zinc cathode. The chemical action of a cell has done a certain amount of work. So we can see that the chemical action has done some work of moving the electrons from copper electrode to the zinc electrode, which is the cathode, that is anode to cathode, and in this process some amount of work is done by the chemical action. If the two plates are connected through a wire, some amount of electrons from the zinc rod will be attracted through the wire to the copper plate. So as the electrons from the copper plate moves towards the zinc electrode, the zinc electrode will become more negatively charged compared to the anode, that is the copper electrode. Because of that, potential difference is there. Because of that, there is a voltage, and whenever you connect a copper wire through the to the both the electrodes. The chemical action of the cell has done a certain amount of work. If the two plates are connected through a wire, some amount of electrons from the zinc rod will be attracted through the wire to a copper plate. So because of the work done by the chemical action, some of the electrons move from the zinc electrode to the copper electrode through a wire which is connected to the two electrodes. The chemical action of the cell now transfers an equal amount of electrons from the copper plate to the zinc rod internally through the cell to maintain original potential difference. This process continues so long as the circuit is complete or so long as there is chemical energy. So, as and when the electrons are moving from zinc electrode to copper electrode through the wire or through the load, the chemical reaction starts increasing, or the rate of chemical reaction starts increasing, and the transfer of electrons from copper to zinc through the electrode will also increase, and this process will continue until the chemical energy is completely used, so long as there is chemical energy. As long as there is chemical energy in the electrolyte, the work is done and amount of electrons are taken from the copper to the zinc, and from zinc to the copper electrode they are moved through the copper conductor which is connected to the two electrodes externally. The flow of electrons to the external wire from zinc rod to the copper plate is called electric current. So whenever the current flows from zinc cathode to anode through the copper wire, that is called as electric current. So what is electric current? The rate of flow of electrons is called as electric current. The potential difference causes current flow to flow while an EMF maintains the potential difference. The potential difference means initially whenever the chemical reaction was taking place, whenever copper conductor was not connected before, the zinc electrode had taken some electrons from the copper, and because of that potential difference causes current to flow while an EMF maintains the potential difference. So EMF is developed. Whatever the difference was created, that is called as EMF, electromotive force, which maintains the potential difference between the two electrodes. Although both EMF and potential difference are measured in volts, they do not mean exactly the same thing. So here is a very important point. Potential difference is the difference in voltages between 2 points. Okay. So what is EMF? Electromotive force. Electromotive force is that force which maintains the potential difference between the 2 points. It is a device which maintains the potential difference between the 2 points, whereas the PD, potential difference, is the difference in the voltage or difference in the charges, amount of charges that is between the 2 points. Concept of resistance. Definition we will understand. The opposition offered by a substance to the flow of electric current is called its resistance. So resistance is the opposition offered to the flow of electrons or to the flow of electric current. Resistance is the electrical friction offered by the substance and causes production of heat with the flow of electric current. The moving electrons collide with atoms or molecules of the substance, each collision resulting in the liberation of minute quantity of heat. So in a pure resistive circuit or pure resistive load, it is the electric friction, means as in case of mechanical engineering we have the friction, road friction to the tires. Similarly, the resistance is the electric friction offered by the substance to the and causes production of heat. Whenever there is friction, there is production of heat, and resistance is the electric friction, and heat is produced whenever the electrons flowing through the substance collide with the atoms and molecules. Some amount of heat is liberated, and that heat is called as I square R loss. Unit of resistance is ohm and is represented by the symbol given in the slide. So what is the unit of resistance? Is the ohm. A wire is said to have a resistance of 1 ohm if a potential difference of 1 volt across its end causes 1 ampere current to flow through it. So whenever the 1 volt 1 ohm resistance is there, means the substance is having 1 ohm resistance. If when the substance is applied with 1 volts potential difference and 1 ampere current flows through the substance, then the substance is said to have 1 ohm resistance. Another way of defining resistance is, a wire is said to have a resistance of 1 ohm if it releases 1 joule or develops 0.24 calories of heat when current of 1 ampere flows through it for 1 second. So if 1 joule of heat is produced by the 1 ohms resistance substance, if 1 joule of heat is produced or 0.24 calories of heat is produced when 1 ampere current flows for 1 second, then the resistance of the substance or the element is said to be 1 ohm. So these are the two ways of defining the resistance of the substance. Resistance is nothing but the electric friction offered to the flow of electric current, or it is also called as the opposition force for the electric current to flow through the substance. That is called as the resistance of the substance. Concept of electric power. So we'll understand what is power of, or the electric power. The rate at which work is done in an electric circuit is called electric power. So electric power is the work done in electric circuit divided by time. So we say that power is so much watts. Okay, so what is power then? Electric power is work done in electric circuit. How much amount of work is done with respect to time, then it is called as electric power. When voltage is applied to the circuit, it causes current, that is electrons to flow through it. Work is done in moving the electrons in the circuit. Thus work done in moving the electrons in a unit time is called as the electric power. So whenever there is flow of electrons, or whenever there is movement of electrons from one electrode to another electrode, then work is done. From one point to another point the electrons are moving, then work is done by the circuit, and thus work done in moving the electrons, or the amount of work done in moving the electrons from one point to another point in a unit time is called as the electric power. V is equal to potential difference across AB in volts. So here 1 volts we have shown, that is the potential difference between A and B point in volts. R is the resistance of AB in ohms. T is the time in seconds for which current flows. So by total change that flows in T seconds is Q is equal to I into coulombs, total charge. So total charge that is flowing through in the form of current from in T seconds is Q equal to I into T. By definition, work V equal to work by Q. Work equal to V star Q equal to Q star I star T, because Q equal to I star T. What is Q? That is the charge, coulombs. Power equal to V into I square R. So we are substituting V in place of as I square R, I square T. So totally is I square R equal to V square by R. So unit of power is joules or seconds, or joules per second, or watts. Electrical energy. So we'll understand what is basically an electrical energy. The total work done in an electric circuit is called electric energy. So the total work done by the electric circuit for the movement of current, or for the movement of electrons, or the flow of current, is called electric energy. Electric energy is electric power into time. So how much power is used, or how much work is done for a particular time, that is called as electric energy. So 1 kilowatt hour, of electrical energy is expended in a circuit of 1 kilowatt, that is 1000 watts of power is supplied for 1 hour. So for 1 hour, if you supply 1000 watts to the electrical circuit, then the amount of energy consumed or amount of energy taken by the electric circuit is 1 kilowatt hour. The electricity bills are made on the basis of total electrical energy consumed by the consumer. So this is a very important concept, that 1 kilowatt hour is the amount of energy consumed by the electric circuit. So the electricity bills are given based on the total energy consumed, total electrical energy consumed by the electrical circuit and by the consumed by the consumer, that is the total electrical energy. So that is defined in kilowatt hour. The unit for charge of electricity is 1 kilowatt hour. This is also called as bolt of trade, BOT, or simply a unit. So we say that there is 1 unit of power consumed. It means that 1 kilowatt hour of electrical energy is consumed by the consumer. So we also say it as BOT, bolt of trade, or simply we call it as a unit. 1 unit means 1 kilowatt hour of energy is consumed for 1 hour. 1 kilowatt of energy is consumed for 1 hour, then it is called as simply 1 unit is consumed. Thus we can say that consumer has consumed 100 units of electricity, that means he has consumed 100 kilowatt hour. So if we say that 100 units of energy is consumed by the particular electric circuit or particular load or particular consumer, then it is said to it is the 100 kilowatt of electrical energy is being consumed. So this way we will summarize that the flow of electrons is the main reason for the current. Means whenever there is flow of electrons, the rate of flow of electrons is called as current. Also we have understood about potential difference. If there is 2 points, if there are 2 points in a circuit, then the potential difference is called as between the 2 points, means higher potential and lower potential. So the electrons flow from or the current flows from higher potential to lower potential. Similarly, we have understood about EMF, electromotive force. Electromotive force is the energy or the chemical work done. Electromotive force is the electrical energy which is used to maintain the potential difference. It is a device. Electromotive force is a device which is a device. Any device that maintains the potential difference, it is called as electromotive force, which it is generated with electromotive force. So then we have understood about electrical energy. Electrical energy is the total work done into time. So it is given in kilowatt hour. This is all applicable for DC load. For similarly, we can understand about AC load. DC load means we have only resistance values. Then if there is AC load, then we have inductance and capacitance elements. So for that, the load or the electrical energy consumed can be told in the form of kVAh. So kilowatt hour is the DC load, whereas kVAh is the AC load. So whenever we are studying about AC circuits and AC loads, we will understand what is inductance, what is capacitance. These are also a type of opposition offered to the flow of electrons. Inductance and capacitance are also the oppositions offered to the flow of current, and that is also known as reactance and for inductor and capacitance for inductance and capacitance, reactance and reactive power and capacitive power reactance. So inductive reactance and capacitive reactance are the oppositions offered by the elements like inductors and capacitors to the electric circuit, that is the AC circuit. So this is all about basics of electrical engineering, and we are understood about power, electrical energy, potential difference, EMF, and some of the basic concepts like resistance, which is also the kilowatt hour and kVAh. So with this I conclude the unit 1.1 in the electric and magnetic circuits, and in the next chapter we will understand more about the different concepts in electric and magnetic circuits. Thank you.